In 1958, an American physicist called David Finkelstein used Albert Einstein's general theory of relativity, a much more accurate theory of gravity, to prove that black holes could indeed exist.
Black holes remain, to this day, one of the most mysterious and terrifying things about outer space. Imagine this huge, and I mean unbelievably, inconceivably huge, mass that just swallows in everything, ranging from man-made spacecrafts to even light. It's not just the fact that anything would get sucked right inside, there's also the uncertainty that surrounds it.
Which deforms space-time. So matter deforms space-time, and then space-time tells matter in turn how to move around it. And you can get enough matter into a small enough region that it punctures space-time, and that even light can't escape. The force of gravity keeps even light inside.
After all, whatever we do know about the literally incredibly vast outer space is very limited. However, even with the knowledge that might barely scratch the surface, we now know that white holes exist. Technically, they are what the polar opposite of a black hole would be like. And no, that doesn't make the concept of white holes any less menacing and scary than their black hole counterparts. So strap yourself into your spaceships as we go on a tour around everything we know about the discovery of white holes up to this point. Now, you have to understand that the discovery of a white hole had the entire space science community in complete and utter frenzy. People were very excited about stumbling upon another element of space, and figuring out the physics behind them then became the top priority of researchers working in astronomy. And why wouldn't it be? What exactly white holes are was unknown to the human world until very recently, and we still can't confidently say that we know everything there could possibly be to know about these mysterious celestial structures. Doesn't the prospect of the unknown give you goosebumps? Because if that's the case, you're definitely not alone. It is popularly agreed that you wouldn't want to get anywhere too close to a black hole. A black hole forms when a huge star collapses into itself after its lifespan runs out. This process also gives birth to a nebula that shoots off the debris of the dying star into space. In fact, according to one school of thought, there is a black hole at the core of every galaxy, including our own. A black hole has such enormous mass that its force of attraction can suck in everything. And when I say everything, I mean even light. So if you do go near one, you will just be sucked right in. Well, I will be lying if I said that I never wondered what it will be like inside a black hole. If you have ever wondered the same thing, do drop us a comment to let me know that I'm not the only one. The black hole that gave birth to and is at the core of the Milky Way is called Sagittarius, and apparently it would fit 4 million of our suns. It wouldn't even be a tight fit. So yeah, if you're wondering why we aren't getting sucked into it already, it's because luckily, we just happen to be far away enough. I mean, talk about convenient positioning. And no, our sun will never actually become a black hole. Of course, it will die and cease being a star eventually, but it just doesn't have enough mass to turn into a black hole. So what will happen is that it will become a white dwarf after playing a stint as a red star and a planetary nebula, respectively. Anyway, so that is all there is about a black hole. Coming to what we are actually here to discuss today. A white hole will be just the opposite of everything that we just talked about. So in theory, you can imagine a white hole to be like an inverted black hole in terms of property, structure, and everything else. So everything is strongly pulled into a black hole, right? In a white hole, the force of attraction remains at the same intensity, but it becomes a force of repulsion. So like a black hole can be said to swallow in everything, even light, a white hole is often theorized as expelling light at the same degree as the attractive force of a black hole. A black hole can't technically be seen the way you could point a telescope at the sky and see, say, maybe a planet, but it can be detected by the effect it creates on the things around it, and especially by its intense attractive pull on mass that enters its event horizon. For a white hole too, the same theory applies theoretically, except that it simply repels everything around its event horizon. It is a region that seems to expel space-time. I know. It seems difficult to even think about it hypothetically because it's almost like space-time is just being poured out of nothing. Scientist Schwarzschild's math, which took forward Einstein's theory of relativity and gravity, established Schwarzschild's metric. Obviously, we're not going to get into the complicated rocket science of that here, but basically his theorizations happened around a black hole concept that doesn't change in size and has always existed in the same state. Schwarzschild opines that in an idealized black hole, space and time switch their place and reach a point of singularity in a distant indefinite future, instead of at a location in space. Now, if that sounds entirely mind-boggling to you, you really aren't alone. Drop in with a comment to show solidarity to everyone else who is struggling to come to terms with this concept. Anyway, if you reverse the events of such an idealized black hole, you get a white hole instead of a massive dying star. But where do white holes come from? Well, Stephen Hawking put forward the idea that a black hole emits radiation and evaporates mass through this process. But that means that, as French scientist Carlo Rovelli said, black holes could technically die. Imagine if a black hole continuously loses more mass than it can gain. It will eventually shrink up and die, along with everything else that it swallowed into itself. So all the mass and information that a black hole consumed will once again just cease to exist, along with the black hole. But do you see the flaw here? Information or matter can't be either created or destroyed, which means it can't simply vanish. It will very possibly find a way to be expelled into space, and maybe this is how a white hole is formed. Of course, this would mean that there is no direct cause of the formulation of a white hole, unlike what happens in the case of a black hole, and to be fair, it is almost exclusively conjectured at this point. This is just one of the many possibilities that could lead to the formation of a white hole. In fact, scientists are exploring almost everything they can think of. This expanding space-time has too much in it that we don't understand yet. And while we relentlessly go after all of it, there is so much that still eludes us. Some schools of thought, for example, like the existence of white holes to dark matter. Now, no one even knows the true nature, purpose, or description of dark matter yet. Remember the goosebumps brought on by the unknown? Dark matter certainly triggers them effectively. But that's the thing. While a white hole fits into many scientific narratives about the universe, some scientists are convinced that it is nothing beyond theory, primarily because no one has stumbled upon observing a white hole yet. One could argue that black holes too were in the same position before they were found in the observable space around us. In any case, white holes do go a long way in providing missing puzzle pieces and a bunch of scientific mysteries around the universe. What do you think? Do you think that white holes exist? And from what you've gathered from their nature, do you have any ideas about how they might have come to be? I'd love to get into a fun conversation about this, so fire away into the comments. And if this video interested you, don't forget to like and share it with others. Subscribe to our channel if this is the kind of content you'd like to find on the internet, because I cannot wait to see you again when we are back with our next video.